The next concept we can look at, which stems from some of the concepts from the previous video, is miscibility, or if two solvents are miscible. So two solvents are miscible if they mix in all proportions. So we need to make sure that these solvents are going to be miscible in each other. So if we asked which of the following are miscible with water, and these are listed in table 13.3 of your textbook. So if we look at CH3, CH2, OH, CH3, CO, CH3, CH3, CH2, 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 OH, and HO, CH2, 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 OH. And if we wanted to determine this, we could do an experiment. So we can't do the experiment here over the computer, but we can look at the results that happen. Okay? Yes, the first compound's miscible. This second compound is miscible. The third is not. And the fourth is. So the question is, why and how can we interpret these results right here? So if a compound has oxygen or an OH group, it will be polar. And the polarity is going to increase based on how many OH groups we have on a particular molecule. Okay? To be miscible with water, you must have strong enough interactions to overcome the nonpolar portion of the molecule. So if we look at our four compounds that we have listed here, the OH group is polar. This oxygen right here will make this polar. This OH group over here will make this third molecule polar. And our fourth molecule here, we have two OH groups. Okay? So the more oxygens we have on a particular compound, the more polar that it's going to be, and the more likely this is to be able to mix. Remember that the water has to surround this entire molecule. So for our molecule here that's not miscible, if a water comes in over from this direction, there's not going to be any force of attraction there. And remember we said the like dissolve likes. Polar compounds will dissolve other polar compounds. So in this case right here, we don't have enough of a polar moment to be mixing in all proportions. Whereas for our next molecule here, we have the same number of carbons, but we do have two polar regions here of the molecule, which will help that become more miscible. So it's a fairly common question on an exam or in your homework to be asked which one would be the most likely or the least likely to be miscible. And if you're looking at miscibility in water, make sure you look for polar groups on a particular molecule. And in this case, those polar groups are these OH groups.